Do you want to learn how to set up a DynamoDB database and connect it to your API? In this video, that is exactly what I'm going to show you how to do. Hi guys, my name is Sam with Complete Coding, where our aim is to make you into the best AWS and serverless developer that you can be. In this video, we're going to be taking the API that we built in a previous video, and if you haven't watched that video, I'm going to link it somewhere up here and also in the description below. In that video, we created an API and had a Lambda for both getting some items as well as saving a cart. In this video, we're going to update those Lambdas and add a DynamoDB table, which allows us to store that data in a more realistic way. This also means that every time someone saves your cart to your system, we can have that as a new record in our database. So let's jump onto the computer and get all of that set up. So now that we're back in our AWS console, we're going to quickly review what we did last week and then jump into adding our DynamoDB tables. So if we go into API Gateway, we can look at the API that we deployed last time, which is this shopping API. And what we're going to do is copy the invoke URL and paste that into a browser. And here we can check on the routes, and there are two routes. There is a post cart and there is a get item by item ID. So at the end of our URL, if we add /item/1234, we should get back the item. The way that this returns some data is this get item is calling the integration of this, and this is actually a Lambda authorizer, which if we click on configure is calling our get item Lambda. So if we click on our search terminal and search for Lambda, and I'm going to open this up in a new tab, we can then go and look at this get item Lambda. In here, if we look at the code section and we scroll down, we can see that we get the event. We have some items which are just stored in the code, hard-coded, and then we get the item ID from the path parameters, and then we just get item square brackets item ID, which is going to return either 1, 2, 3, 4 or the data of 5, 6, 7, 8. Now this is good, but what we want to do is we want to set up a Dynamo table to replace this section. The way that we do that is if we go into our search terminal and enter Dynamo. I'm going to open this in again in a new tab. In here, what we can do is we can click on Create Table, and this table is going to be called shopping-items, and at the moment we're just going to have a single partition key of ID. If you want to be able to do querying where you can do different things, then you may need to customize the partition keys and the sort keys. If you're interested in that, I do have another video on that, but for our use case we're just going with an ID partition key. We're going to leave the default settings, and when we get down to here, I'm going to actually change it from default to customize, and instead of running a provisioned instance, I'm going to do on demand. That means that we pay whenever our API and our database are read and written to, but we don't have any ongoing costs. This is good for APIs that are used infrequently, whereas if you're doing every second 10 different reads and writes, then a provisioned instance would be better. So now that we've done that, we can go all the way down to the bottom and click on Create Table, and that will create us a shopping items table. Whilst we're here, we're also going to create one for carts. So if we click Create Table, this time it's going to be called shopping-carts. Again, the partition key is going to be ID, as we're going to be keeping this table relatively simple. Again, in settings, we're going to customize it and change it to on demand, as that will be the best billing mode for us to start with. And scroll all the way down to create table. We can now actually see that our shopping items has been created. So if we go into here, at the moment there are no items in here, and the way that we can see that is if we go under the items section and select our shopping items table, there are no results. What we can actually do is start creating some results. So here if we click Create Item, and by default it's going to come in this form, which is where there is the attribute name and then the value. This does work, but I prefer to edit it in JSON. So on the right hand side there is a thing which allows you to switch between JSON and between a form. So I'm going to go with JSON, and I'm going to untick this button for DynamoDB JSON and leave it just as normal JSON. This is something that I suspect most people will want to do, as DynamoDB adds some extra parameters into the structure of the JSON that it stores, but we don't need that for our case. Now that we've got to this point, what we want to do is go into our Get Lambda, find our hard-coded values, and actually copy that item and go back into our Dynamo table and paste it in here. It's done some interesting formatting, so let's fix that. So as always, we need the ID, and the ID for this one was a string of 1, 2, 3, 4. And as well as that, we also need to make sure that we wrap all of our keys with strings, and all of our strings are the double quoted strings, as this is JSON formatted, not JavaScript formatted. So if we just replace this, size is okay. So the last bit is the price, and the price will be a number. And now we have our record. So if we now click on Create Item, this will create a new item in our database, just like this. What I'm going to do is I'm actually going to duplicate this item. So if we click on here, and under Actions we click Duplicate, this just means we don't have to reformat everything. We're going to create a new record called 5678. And in our case, we changed it from red to blue. So we can do that here. Finally, click Create Item. And now we have two different items in our database. You can do this as many times as you want, with as many different parameters as you would like, to get your database populated. Now what we need to do is update our code to get the items from here, instead of getting the items from our code itself. So here, what we're going to do is we're going to delete this items object and delete this little bit here. And instead, we're going to call dynamo.get. And into this get request, we're going to pass an object with a table name. And this table name, we're going to copy from our DynamoDB tables, so it is shopping items is the table we're making the request to, and paste that in there. And then what we have to do is we have to pass in a key object, and in here we want to say that the ID equals the item ID that we get from our path parameters. Now this all looks good, but one thing is that we haven't defined this Dynamo case. So what we need to do is at the top of our code, we need to import Dynamo from the AWS SDK and then create that. So if we say const AWS equals require the AWS-SDK, and that is by default already installed on every Lambda. Now that we've imported AWS, we can say that const Dynamo equals a new AWS dot DynamoDB dot document client, just like that. And what this is doing is it is creating our database connector, it called Dynamo, and then we can do this GET request. One thing with this GET request is it is going to be an asynchronous request, so we need to add .promise on the end to turn it into a promise instead of a callback based a database request. And that means we also need to add a wait at the start so that we are getting back the value instead of getting back a promise. Now that that has all happened, I need to save this file and click deploy, and that will deploy our new Lambda. So now that we've made all the changes to the code, what we need to do is make sure that this Lambda has permission to read our database. If we scroll up to our configuration section, and then on the left there is a permissions tab. At the moment we have this role, which only has permission to access CloudWatch logs, which is where the logs end up. What we want to do is actually edit this. So if we click on edit, we can open up our GetItem role, and if we click on this button, it will take us to the IAM console where we can give it extra permissions to be able to read from Dynamo. So in here at the moment, it only has the ability to execute a Lambda, but what we can do is we can either attach a policy or we can add an inline policy. In my case, I'm going to add an inline policy. Here, I want to say that we can access DynamoDB. And I want to say that I can do any of the read requests. And under resources, I could either pick a specific table. So I could go down to here and add the ARN of that Dynamo table. But for now, I'm just going to click on all resources, review this policy, and we're going to see that DynamoDB read full access is assigned to this policy. So give it a name and I'm going to call it Dynamo full read and create that policy. And now this policy has been created and it is assigned to the GetItem role. That GetItem role is available on our Lambda. So this all means that I can now do a request to this Lambda and it is able to access DynamoDB. If I open up a browser and refresh this page, we're now getting back a slightly different structure. Here, when we do a get, we get back an item from DynamoDB, and that item is the object that we've stored in there. This just means that we definitely know that we are returning exactly the data from DynamoDB, and to prove that, I can change something in 1, 2, 3, 4. So if we go into items and shopping items, find record 1234, change it from red to purple, and save this change. Once this has changed, we can go back into our browser, refresh the page, and we can see that now the colour is purple and the description is a purple t-shirt. That is how quickly the database updates and new data can be provided to your API. So obviously this is getting an item, so we want to clean this up a little bit. To clean this up, what we're going to do is change this from being item to being record, and we are going to switch that out. So here we're checking if the record exists, and at the very end we want to stringify record.item, which is going to be just the data from the database. If we deploy this again and now refresh our page, we get a record, which is exactly what we would expect to get before. So that's a little extra step we need to do to clear up the data we get back from DynamoDB. Now this is how you add data requests. So we're requesting the get record from the shoppings table. So we need to do something similar in the create cart. I'm going to copy these first two lines, as we're going to use those two again in the other Lambda. So at the top, if we search for Lambda one more time, in here, if we go to create cart, we can start updating this code. So if we paste those first two lines in at the top, we get the body and we console log out the body. And I have this comment from last time saying this is where you would add the db.write. So here, what we're going to do is we're going to now use dynamo.put. And the reason it is a put is this could either be a new record that we are writing to the database, or it could be actually that you're updating an existing one. So if you create a cart with the same name, then that will be added in here. The parameters for this are again a table name, and I'm going to copy this from DynamoDB. So it is shopping-carts. As well as that, we then need to pass up the item data. So we have the item, and what I'm just going to do is I'm going to pass the whole body in here. Now this does mean that we have to expect the user to pass up an ID, so I'm going to change it very slightly. We're going to pass in an object that has the body, but we're going to spread the parameters of the body into here. All that does is it basically just copies each of the keys and values into this object. I'm then going to add my own ID, and that for now is going to be math.random times by a very large number, and this is just one way of making a unique value. And because we just want this to be a single value, we want to do math.floor. So now there are no decimal places. And then finally, we want to do toString. So we can actually test this out. So if you copy all of this, open up a browser console, and you paste that in, what you should do is you should get a random string of numbers, and that is going to become our ID. So if I now close the console and go back to here, we're going to paste in our body plus a random ID. Now that is all done, what we need to do is just make sure that we await this and add a .promise at the end. as this turns the Dynamo put into an async thing that returns a promise, and awaiting it makes sure that it doesn't run the next line of code until this has completed. So if we save this and deploy it, we need to do one more thing, which is configure this to be able to write to Dynamo. So again, in the configurations and permissions, if we find our role, we can open that up inside IAM. And as before, this just has the basic IAM execution role. So if we add another inline policy, again, this time we're going to be going for a Dynamo. But in here, we want to write and have write permissions. Again, for now, we're going to go with all resources. But if you wanted to have more fine-grained control, you could limit it to just a specific table. And if I hit review policy, we can see that there is a DynamoDB access policy of write. So I'm going to call this Dynamo-Lambda-write. And if I create this policy, that is now attached to the create cart role, and that create cart role is used by this Lambda. So now that we've updated that role, we can head over into Postman, and I actually have the API request from last week's video. What we want to do is change the data in here a little bit. So instead of it being the cart ID, I want to pass up the items, and that is going to be an array. It's going to have item 1, 2, 3, 4, a second item of 1, 2, 3, 4, and then one item of 5, 6, 7, 8. If we do that, we can now send this request, making sure that we're doing a post request to our URL/cart and passing up some JSON data. If we send this, we get back a 201 response with message cart created. And if we go back into our AWS console, search for our items inside DynamoDB and look for shopping carts, I can refresh this, and I actually have here a random ID. It has an owner of Sam and items of 1, 2, 3, 4, 1, 2, 3, 4, and 5, 6, 7, 8. So we've managed to successfully get data from a DynamoDB table, as well as adding new data to that same database. What we could do in a next bit is we could create a get shopping cart. And what we could do is we could pass up the ID, which is generated, into that API, and we could do a get on this shopping carts table, which would allow us to use those for other purposes. In this video, we've managed to update our existing API to add a DynamoDB database to the whole infrastructure. Every time someone tries to do a get on an item, we do a lookup in Dynamo to get that item. And every time they create a new cart, we are saving that data to a different table in Dynamo. This is definitely a more realistic use case for APIs, and hopefully it helps you understand how you can start to use a Dynamo table inside a Lambda, which is used for an API. If you've learned something new in this video, make sure to hit that thumbs up button, as it really helps the channel and helps more developers just like yourselves learn about DynamoDB and APIs. And if you haven't done already, make sure to subscribe down here, as we release regular content on AWS and Serverless.